The circle C has centre 0, 0 and radius 5 units. Write down the equation of C. This question involves the equation of a circle. So the first thing to do is to open up our formula book to page 19 and look at the formula for this. It states that the equation of a circle with centre HK and radius r is x minus h all squared plus y minus k all squared is equal to r squared. Here, h and k refer to the coordinates of the centre. Our circle has centre 0, 0. So h is equal to 0 and k is equal to 0. R refers to the radius, and in our question, the radius is 5 units. So r is equal to 5. From here, all we have to do is to sub these values into our formula. Here, we can simplify a bit. X minus 0 is just x, y minus 0 is just y, and 5 squared is equal to 25. So our final answer here is x squared plus y squared is equal to 25. Part B. The diagram shows a semicircle which is part of C. The point P is equal to minus 4k, where k is greater than 0, is on the semicircle. Find the value of k. So we're told that this point P is on the circle. There's a helpful fact which will allow us to use this information. A point, xy, is on our circle if and only if it satisfies the equation of the circle. We know that the point P is equal to minus 4k is on the circle. Since P has an x coordinate of minus 4 and a y coordinate of k, x equals minus 4 and y equals k must satisfy the equation of the circle. So what we'll do is we'll take the equation we found in part A and sub in x is equal to minus 4 and y is equal to k. So we found that 16 plus k squared is equal to 25. Our goal here is to find the value of k. In other words, to isolate it all by itself on one side of the equation. To do this, we'll need to remove the 16 and the square. Let's start by removing the 16. This 16 represents addition. The inverse of addition is subtraction, so to remove plus 16, we should subtract 16 from both sides. Now, we'll need to remove the square. The inverse of a square is a square root, so here we should square root both sides of the equation. We have to be careful when we have equations involving squares. If we type the square root of 9 into our calculator, we'll get the answer +3. However, the negative version of this, -3, also squares to 9. So here we'll have two possible answers. K is equal to +3 and K is equal to -3. Though in this question, we're told that K must be greater than 0. So this rules out the -3. So our final answer here is that K is equal to 3. Part II. Show that the triangle ABP is right angled at P. To help us visualize this, let's draw in the lines from A to P and P to B. There's a useful fact which will help us here. An angle which stands on a diameter of a circle is always equal to 90 degrees. In other words, it's a right angle. In our picture, AB is a diameter of the circle. The angle at P is standing on this diameter. Our fact tells us that any angle standing on a diameter must be a right angle. Hence, the angle at P is a right angle. Part C. Find the area of the region which is inside the semicircle but outside the triangle ABP. Give your answer in square units, correct to 2 decimal places. The region inside the semicircle but outside the triangle corresponds to this red region in the diagram. It's quite difficult to find the area of this region directly. However, we could find it as follows. We can start with the full area of the semicircle and then subtract away the area of the triangle. So once we calculate these two areas, we'll be able to find our answer. Let's start with the area of the semicircle. We were told at the top of the question that our circle has a radius of 5. There's a result in the formula book on page 8 for the area of a circle. It says that a circle with radius r has area A given by A is equal to pi r squared. In our scenario, we have a radius of 5. So to find the area of the full circle, we should sub in r is equal to 5. So the area of the full circle is 78.5398. However, we don't have a full circle. we have a semicircle. Well, a semicircle is half of a circle, so it will have half of the area. So to find the area of the semicircle, we find a half of the number we just found. Now, let's turn our attention to the area of the triangle. There's a formula on page 9 of the formula book for calculating the area of a triangle. It says that a triangle with a base of A and a perpendicular height of H has area, capital A, given by capital A is equal to a half times little a times H. To use this formula, we'll need to identify the base A and the perpendicular height H. In our triangle, the base runs flat straight along the x-axis, and it goes from an x value of -5 to an x value of +5. This is a distance of 10 units. So our base A is equal to 10. To find our perpendicular height, we should look at the height of our point P. In a previous part of the question, we found that K is equal to 3. This means that P has a y coordinate of 3. In other words, its height is 3. So the perpendicular height of our triangle, H, is equal to 3. Now that we know the base and the perpendicular height, we can sub into our formula for the area of a triangle. So, we found that the area of the semicircle was 39.2699 and the area of the triangle was 15. As we noted at the beginning, to get our answer, all we have to do is subtract away these two areas. Rounded to 2 decimal places, our final answer is 24.27 square units.